Hello everyone, this is Sir Brian Orlasan Cordova and welcome back to another calculus class. So for today, our topic is applied optimization. So this is the application of derivatives in optimization problems. We have the steps in solving applied optimization problems. So number one is understand the problem. So lagi naman, read the problem until you understand it and find what is the given unknown quantities to be optimized. Number two, draw a picture or diagrams, label any parts that may be important. Number three, introduce variables. So you can list every relation in the picture and as an equation. Number four, write an equation or equations for the unknown quantities in terms of the other unknown. Or you can express an unknown as a function of a single variable or into equations to unknown. Number five, test critical points and endpoints in the domain of the unknown and use what you know about the functions and use the first and second derivative to identify and classify the critical points. Example number one, an open top box is to be made by cutting small congruent squares from the corners of a 12-inch by 12-inch sheet of tin and bending up the sides. How large should the square cut from the corners to make the box hold as much as possible? So as a solution, so pakita na muna natin what is being given. So ang kukunin natin is an open top box made from cutting small congruent squares from the corners of a sheet of tin, 12-inch by 12-inch yung size. So meron tayong square sheet of tin, 12-inch by 12-inch. And kakat tayo ng small congruent squares from the corners and let X be the side of the corner squares to be cut. So ito yung mga corner squares and yung sides ng small squares na yon ay equal sa X. That is the unknown side because yun yung tinatanong. How large should the square cut from the corners? So the size of the congruent squares na ikakat natin doon sa corners, yun yung unknown. Now, actually, i-fold natin itong edges na to make a open top box. Now, the length of this side or yung magiging base or edge ng square box would be 12 minus dalawang x because of this side nung dalawang corner squares. And yung height would be yung folded na pataas, which is x lang din. And the thing na i-optimize natin is yung volume to make the box hold as much as possible. So, i-maximize natin yung volume. Okay? And to maximize the volume, we need the formula for the volume. And since square box yun, the area of the base times the height. That is, square natin yung edge ng box times the height, which is x. So this is the formula for the volume, which can be shown as a function of x. So v of x is equal to 12 minus 2x quantity square times x. Or we can simply make it a polynomial, 144x minus 48x squared plus 4x cubed. So make sure lang na yung x natin is from 0 to 6 because hanggang 12 lang yung ating size ng sheet of tin. So meaning hanggang kalahati lang yung pwede mong i-cut na dalawang corner squares. So that is hanggang 6 lang yung size ng x. From 0 to 6 only. So that is our domain for the values of x. Okay? Now, to graph that, we have, so from 0 to 6 yung ating values of x. Now, to maximize this, we need to find the critical points. So use the first and second derivative of the formula of the volume. So the first derivative for x is 144 minus 2 times 48 is 96x plus 12x squared. Then para mas madali natin makuha yung zeros, factor this out. So common factor is 12 times 12 minus 8x plus x squared. then ito ay pwede pa nating i-factor into 12 times 2 minus x times 6 minus x. So the critical points would be x is equal to 2 and x is equal to 6, where yung first derivative could be 0. And that is the zeros of this polynomial. So at x is equal to 2 and at the endpoint x is equal to 6. So that is our critical points. So at the endpoints, evaluate natin. So v of 0, so 0 lang din yung volume because 0, 0, 0. At x is equal to 6, so substitute lang natin yung 6 do sa x. This will also become 0 because kapag kinat natin yung squares dito, wala na tayong ifo-fold, mauubos na yung sheet of tin natin. Okay, so at the endpoint, we have 0 values. And at critical point, substituting the x as 2, we have 128 cubic inches since inches yung units. So this is the volume dun sa x is equal to 2. So since it is a critical point, it is a maximum point. So then the question is, how large should the square cut from the corners? Therefore, x is 2 inches. So 2 inches lang yung dimension ng squares na ikakat mo para ma-maximize yung volume, and the maximum volume would be 128 cubic inches. Example number 2. You have been asked to design a 1-liter can shaped like a right circular cylinder. What dimensions will use the least material? So, patitiran ito. So, a 1-liter can na shape niya ay right circular cylinder. So, this is a cylinder. And yung dimension ang tinatanong. Ang i-optimize natin is least material. So, yung material ay nandun lang sa mismong surface. So, the dimensions are, which is the radius of the circle doon sa bases and yung height ng cylinder. So, recall lang natin, para makuha natin yung dimensions ng radius and yung height, yung liter, hindi siya dimension ng length, kundi volume. So, this can be changed into a linear measurement by this equality or conversion. So 1 liter is actually 1,000 cubic centimeter. So in centimeter, makakuha natin as the dimension of radius and height. So linear measurement na siya. So ang i-optimize natin dito is the surface area because it is the material na lalagyan. Yung mismong enclosure lang, which is the surface areas. Since there is one restriction that 1 liter lang yung gagamitin natin, which is the volume. So, kailangan natin yung volume, which is, ang formula is pi r squared h. So, area of the circle, base, times the height, which is equal to 1,000 cubic centimeter. Now, this can be our restriction to have a relation between two variables. So, let's say h is equal to 1,000 over pi r squared na lang. So, meron na tayong yung variable na h can be shown as function of r. So let's have the formula for the area or the total surface area. So area of the base is 2 pi r squared. So dalawang area ng circle, which is 2 bases, plus 2 pi r h, which is yung area ng surface dun sa side, yung cylindrical side, which is 2 pi r is yung circumference nung ito, and yung height is ito. So, multiply lang para makuha yung area. Now, this is what we will optimize. Now, since meron tayong dalawang variable, kailangan lang natin ng isa. Now, since ginamit natin ito for the relationship between h and r, so substitute natin. H is equal to 1,000 over pi r squared. Substitute natin. Now, the area now is a function of one variable r. So, area is equal to 2 pi r squared plus 2,000. So, 2 times 1,000 over r. So, pi r, cancel yung isang r. Okay? Now, let's have a diagram para sa maximization. So, if maliit yung radius na gagamitin natin, so maliit yung circle niya. Pero yung area, kung maliit ito, ito yung magiging dominant term. So, lalaki yung value nito, lalaki yung area. Pero maliit yung base natin or yung circumference lang ng bases. So, ibig sabihin, it is tall and thin. So, maliit lang yung circle, pero mataas para makuha niya yung 1 liter. Pero kapag malaki yung ginamit nating R, so malaki yung area ng base, pero kapag malaki ito, liliit na yung value nito. Therefore, para makuha pa rin yung 1 liter, short and wide naman yung itsura ng can. Okay? So, kailangan lang natin balanse. So, the goal is to find a radius greater than 0 that minimizes the total surface area. Okay? Now, let's use the first derivative to find the critical point for R. So, the critical value for R na kung saan ma-maximize or minimize natin yung area. So, the first derivative is 2 times 2 is 4 pi r. R na lang siya. Minus, since this is negative 1, so negative 2,000. Then, negative 1 minus 1 is negative 2. So, r squared nasa denominator. So, and yung second derivative is equal to 4 pi plus, since this is negative 2, so negative 2 times negative 2,000, which is positive 4,000, then r cubed na siya. Okay. Now, equate natin sa 0 to. So, to find the zeros and to get the critical points of r, cross multiply yung r squared dun sa r. We have 4r cubed is equal to 2,000. Then, simplifying this, solving for r, we have 2,000 over 4 is 500 over pi. So, we have r is equal to cube root of 500 over pi, which is approximately 5.42 centimeter. So, this can be our critical point on r, where it can be the r na mag-minimize dun sa surface area or the total surface area. Pero 1 liter pa rin yung kalalabasan. And for this one, kahit anong values ng r cube, is positive yung r natin, so positive dito, it will not have a negative value. So kung positive ito, concave upward yung ating curve. Okay? So that means at this point, kung saan yung slope or the first derivative natin ng area is 0, so slope is 0, at this point, it can be our minimum area. Now, to get the other dimension, meron na tayong radius. To find the height, kasi ang tinatanong ay what dimensions. So, substitute natin yung value ng r dito sa formula ng height. So, by some algebra, this will be equal to 2 cube root of 5 over pi, which is, itong cube root of 500 over pi is actually r. So, h is equal to 2r. So, please verify this na lang. So, by some algebra, magiging equal itong 1,000 over pi r squared dito. So, h is equal to 2r. So, the dimension of height is approximately twice the radius, which is 10.84 centimeter. Now, these are the dimension that will use the least material to have a 1 liter can shaped like a circular cylinder. So, ibig sabihin, kailangan equal yung diameter dun sa height because 2r is the diameter. The diameter nito is equal dun sa height para ma-minimize yung surface area to have the same 1 liter volume. Example number 3. A rectangle is to be inscribed in a semicircle of radius 2. What is the largest area the rectangle can have and what are its dimensions? So, pakita natin ngayon yung figure. A semicircle of radius 2. So, yan. So, from 0 to 2 and 0 to negative 2. A rectangle is inscribed in that semicircle. So, we have that rectangle. So, the equation for the circle is x squared plus y squared is equal to 4, which is yung square ng radius 2. And yung radius natin from the origin up to one of the corner ng rectangle is 2 also, since it is the radius. So as a solution, So let x square root of 4 minus x squared be the coordinates of the corner of the rectangle. So meaning, yung y component, yung point na to, is equal to this height. Okay? So yung x naman is from 0 to x. Okay? So the length of the rectangle is 2x because from 0 to x, tsaka 0 to negative x. So twice ng x. And yung height niya is yung y component ng point na to, which is square root of 4 minus x squared galing dito. Okay? And the area of the rectangle, which is yun yung i-maximize natin, what is the largest area the rectangle can have. So that is the length times height, which is 2x times square root of 4 minus x squared. So the domain of the values of x is from 0 to positive 2. So hanggang dito lang yung values of x. From the origin up to the radius of the semicircle. So ang goal natin is to find the absolute maximum for the area. And yung area natin is pwedeng ipakita as a function of the variable x. So a of x is equal to 2x squared of 4 minus x squared. And yung domain natin is ito, from 0 to 2. So hanapin natin yung maximum points. Now to get a prime of x, so this is actually a product rule. So 2x times square root of 4 minus x squared. We have 2x times the derivative of 4 minus x squared raised to 1/2 plus derivative of 2x is 2 times square root of 4 minus x squared. Now, to get the derivative of this, we have 2x times yung exponent is 1/2 times yung inner function 4 minus x squared. Then 1/2 minus 1 is negative 1/2 times yung derivative ng inner function which is 4 minus x squared is negative 2x. Now we can cancel 2 times 1/2. So ang matitira is negative 2x times x is negative 2x squared over, so since naka-negative yon, ibaba na natin. So square root of 4 minus x squared. Okay? Then plus yung 2 times square root of 4 minus x squared. Now multiplying both sides by the denominator of this one. So we have negative 2x squared na lang plus 2 times. So since square siya times another square root of that, we have 4 minus x squared. Now let's find the values of x na mag-i-equal ito sa 0. This is equal to 2 times 4 is 8. Then negative 2x squared plus 2 times negative x squared is 4x squared na siya. Then transpose negative 4x squared. So sa kabila, then divided both sides by 4, we have x squared is equal to 2. So therefore, yung x ay equal sa square root of 2 or x is equal to negative square root of 2. So it's either dito or dito. But ang hinahanap natin is positive x. So this one is hindi included. So this will become our critical point. So at critical point, a of square root of 2. So substitute natin dun sa function dito. So 2 times square root of 2 times square root of 4 minus square root of 2 squared is 2. Therefore, we have area is equal to 4. And at the endpoints, a of 0, 0. So 0 siya. A of 2, 2 times 2 is 4. But 2 squared is 4. 4 minus 4 is 0. So times 0 pa rin. So 0 lang din. So therefore, the maximum area is equal to 4. So the dimension of the rectangle would be, yung height niya is square root of 4 minus 2 is square root of 2. So square root of 2 high by 2 times square root of 2 long. So this is the dimension of the rectangle and a maximum area of 4 square units. And that's all for this class. And thank you.